I think today, Kevin, we are going to talk about some thermochemistry and internal energy, and it'll turn into exothermic and endothermic as we just try to wrap our heads around a figure in the text. Okay?
Yeah, that sounds good.
So let me share my screen and bring up a figure from the text. Okay, so this is in chapter 5. I know that I sometimes struggle, and I remember when I was an undergraduate, I struggled, and probably many times throughout my career, I've struggled to try to understand when something is part of the system and when something is part of the surroundings, and what does that have to do with thermochemistry and being able to keep track of what's going on. Okay, so I'm going to try and do some things here that will hopefully make this diagram a little more understandable. Okay.
Okay.
So I'm gonna reproduce it over here on the piece of paper here for a second. Okay. So this is essentially the diagram that we were just looking at in the book. It's got this system that's a nice square box, and then there's the rest of the universe around it outside, and you can have some changes occur between the system and the surroundings, but basically your two choices boil down to heat going from the universe or the surroundings into the system, or heat leaving that system, or, well, I'm going to leave this one for the last. We're going to do work done by the system or work done on the system. Okay, and let's start by looking at heat in and out of the system first. Okay, so this is a nice square box. Just so happens that we were at a nice cube a few days ago. Looks a lot like this. Let me know when you recognize what I'm drawing.
Is that a die, Dr. Hunter?
No, nice try, nice try.
Oh, it's a stove.
It's a stove. It's my stove.
It's an oven.
Oh, I was hoping you'd get it sooner than that, but nonetheless. Okay, it's a stove, and it looks just like my box. Okay, so we're going to use that. Okay, so we're going to define the stove as being the system. So I better write the word stove on it, right? And I'm going to cross this one out because this is going to be the surroundings. Okay. And so the first question I have for you, Kevin, is if you're going to burn yourself on the stove, where are you going to touch?
Right where the gas and the fire comes out on the.
Sure. Yeah. In my head, this was an electric stove, but it could very well be a gas stove. Okay. I don't know how you were supposed to know that, but nonetheless. Okay. So, all right. So if you burn yourself, okay, if you take your hand and you come in here accidentally and you touch right here and you burn yourself, do you think energy is being transferred to you or from you?
I would think energy is being transferred to me, right?
Yes. Yeah, exactly. So the energy comes off the stove, the heat producing device, and it goes into your finger. Right? That's a hand, by the way, with a finger, if you're wondering about my drawing. That's a hand. Okay, so that is heat, energy, leaving the stove and going into your finger. So from the stove's perspective, it gave up some energy, right? It transferred heat out of the stove. Okay? Let's go back and look at the diagram again here for just a second. So here is heat being transferred out of the system. And in this case, we describe it as being a negative amount of energy. It's energy flowing out. And so in this case, Q is negative from the stove's perspective, right? Because the stove lost energy and it went into your finger. Fair enough?
Okay, that makes sense.
Okay. So this from the stove's perspective, it lost energy. And so from the stove's perspective, is it an exothermic or endothermic process?
It would be exothermic.
Right. From the system's perspective, it lost heat. So in this direction, it's exothermic, right?
Right. It's leaving the box. Exo out.
It's exactly. It's leaving the box. The stove, the box is losing energy, and it's going into your finger. Oh, from your finger's perspective, it gained energy, right? So from your finger's perspective, it was an endothermic process, right? Because it got the energy. And so the heat was, so now if we say, oh, instead of thinking about the stoves being the system, and we think about, oh, your hand as being the system, the hand gains some energy, right?
Yeah.
If the hand gains energy, oh, that's heat going into a system, right? So if I draw below this, oh, here we go. We'll trace my fingers. That's better. You don't get my whole hand. Okay, so now my hand is the system, right? And the heat flowed into my hand, right? From the outside, from an outside source. So that's heat flowing into the system. Q, in this case, is going to be positive. So it's one of the challenges is to figure out what is the system in the particular case and what's the surroundings. We started off by saying the stove is the system and everything else is the surroundings. But it didn't take very long for us to decide, you know what, let's pretend that my hand is the system, right? Is the thing that we care about. And that same amount of heat that was transferred out of the stove ended up being transferred into my hand. Or, well, at least the part that didn't go into the air around it, but overall. Okay?
Okay.
All right. So that says that we can pay attention to, if we can figure out what is the system and what is the surroundings, then we can describe things as being the heat energy leaving the system, and that might be exothermic, or if energy is entering the system, Q is positive, that would be endothermic. How am I doing?
So far, so good. It's just all about defining the system, right?
It's all about defining the system. Yeah. Okay. That's 50% of the diagram. Since I've drawn it like this, I'm gonna recreate it on another page. Okay.
Yeah, sure.
Okay. So we did heat in and out, and now we're gonna do work in and out. Okay. Now this one I think is harder. It's harder because we don't typically see or see the work in the way that it might be convenient to see it, right? It's often described as pressure volume work. And what in the world is pressure volume work? Not clear to me. So what we're going to do is we're going to look at some other different types of work. Okay, so can you think of a circumstance on which either a system does some work or some work is done on a system?
excuse me. Maybe a hydraulic press or something.
Okay.
Like
Okay. Sure, like a press or a jack or something like that. How about if we talked about like driving a car up a hill?
Yeah.
Okay. It's pretty clear that when a car goes up a hill, some work is being done. Do you agree with that?
Yes.
Okay. Now we're going to apply the same scenario. What are we going to define as being the system in this case, and what are we going to define as being the surroundings?
I would think that the car would be the system, right?
Okay. So the car is the system. Okay. So if the car is the system, what is the work that the car is doing?
It is using the gas, using the engine to generate work to go up the hill.
Right. It's fighting against gravity, right? Right. That's the way that it is pushing against the universe, right? The universe isn't just allowing that to happen. The car has to work and fight against the universe. Okay. So what that says, let's go back to the chart for a second. Okay. So is the system doing work on the universe, or is the universe doing work on the system?
We just described the car fighting against the universe, against gravity. So
right.
The system has to be doing work on the surroundings.
Right. So if the system is doing work on the surroundings, that's work being transferred out. And so the work is a negative term.
Even though it feels like the car is doing the work and it would feel positive, in this case, it's a negative number.
Yeah. I think it's so the work is negative. And I think it's kind of like when you put your hand next to the stove and the stove feels warm. And so you're feeling energy and you think, oh, it must be exothermic. Yeah, it's exothermic from the stove's perspective, but it's endothermic from your perspective, right? And so it's hard to separate ourselves from what we experience. But our feelings weren't defined as being the system. The car was the system, right? And so it did the work fighting against gravity, and so the work is negative. Conversely, we let the car roll down the hill afterwards. Now we're in the other half where the work is being done on the system, right? And the work is being transferred into the system, and so work would in this case be positive. So work is negative when the system is doing the work on the surroundings. Work is positive when the surroundings do the work on the system. And so the car fighting against gravity is this side. The car rolling back down the hill. That's when the universe does the work on the car, right? It uses gravity to drag it back, right? And so this case, work is positive. And that's over here. So that's one way of maybe helping people to see that the directions and the values of heat and work and the system as they're done by the system on the surroundings or the surroundings on the system. If you can wrap your head around the stove and the car, you know, and I know, it runs based on the gasoline that's put in it. So you know that the making and breaking of bonds that takes place produces some energy, drives the car up the hill. That will help you to say, okay, I understand how the heat energy of the reaction is taking place and what that must be doing in terms of the work that's produced. You don't need to put gas in your car to make it go downhill, right? And so if you can begin to think about, okay, so in those cases, I don't need to supply internal energy to make the reaction go and to make then I must be getting some work being done by the surroundings on my car or on my system. So that's one of the ways that I try to keep track of what's going on in this diagram of showing the system and the surroundings and the heat and work sign conventions of thermodynamics. So hopefully that will help some students.
Yep, hopefully.
Okay, awesome. Well, really nice to talk to you this afternoon, Kevin.
Yep, great talking to you, Dr. Hunter.